Hello students, welcome to the online learning platform of Brilliant Public School. In this video, we are going to discuss about the three laws of motion. It is a topic of chapter 9 of class 9th physics. Right? Let us start. So, Sir Isaac Newton has given three different laws of motion. The first law of motion states that the first law of motion is stated as an object remains in a state of rest or of uniform motion in a straight line unless and until an external force is applied on it. That means if an object is in rest, it tends to be in rest. If an object is in motion, it tends to be in motion unless and until an external force is applied on it. Okay. So, or you can say, in other words, all object resist a change in its state of motion. In qualitative way, the tendency of undisturbed objects to stay at rest or keep moving with the same velocity is called inertia. So, that is inertia. Inertia is nothing but tendency to remain at its state of any object. That is called inertia. This is why the first law of motion is also called as law of inertia. Okay. So now let us understand this with an example. So Newton's first law of motion. So you see in the figure, it is clearly visible a football. Let us assume that this football is at rest. Okay. So this is at rest. This will remain at rest unless and until you will apply an external force on it, on this football. Or when you will kick that football, then only the football will be move. Otherwise, the football will always be at rest. That is the first law of first law of motion. Okay, the half of the first law of motion. So see, the first law of Newton's first law of motion has two parts. Okay, the first one is called inertia of rest. The second part is called inertia of motion. Okay, so this condition, when we are thinking about any object which is at rest, that comes in this inertia of rest. Okay, so unless and until you will apply an external force on this football, it will remain at rest. This is Newton's law. Suppose someone is kicking that ball. When you will kick a football, what will happen? The football will be in motion. Okay, so Newton's law says that if the ball is in motion, it will remain in motion unless and until an external force is applied on it. What happens in the ground? You might have seen that when you apply a force on a football, what happens? After some time, it stops. It stops due to the friction provided by the air and the friction provided by the surface of the earth on that football. Otherwise, when you will apply any force on any football in space or in the absence of air or any surface to provide the friction, it will continuously moving. It will be continuously moving. So this is a Newton's first law of motion. Okay, so let us consider another example. It's a very important topic. Like see, wearing a seat belt in a car while driving is an example of Newton's first law of motion. Okay. Now you can clearly see a picture where a person is sitting on a bus. So bus starts. When the bus starts moving, any person sitting on the bus feels a force in backward direction. What happens when the bus was at rest? The person sitting in the bus was also at rest. Suddenly when the bus starts, what happens? The bus or the surface of the bus or the seat, it will be in motion. It will start motion because the bus is in motion. The bus starts from the rest. So it will also be in motion. But the person who is sitting in a seat, he will be at rest. So suddenly it will move backward. Okay. So this is a condition why we have to apply always a seat belt. just to avoid a fatal injury. Like, see, when the bus suddenly stops, suppose a person is sitting in this posture, so when the bus suddenly stops, a person will feel a force in the forward direction or a jerk in the forward direction. Why? Because when the bus was in motion, the person along, means the person sitting in the bus, he was also in motion. When the bus suddenly stops, the bus is at rest now, but the person is still in motion. That's why he feels a force in the forward direction. Again, this is also an example of it. Suppose any person is riding a bicycle. Suddenly, in the mid of the road, some object comes. Suppose this is an obstacle to that bicycle. What will happen when the bicycle will strike to this block? When this bicycle will strike to this block, what will happen? The bicycle will come at rest suddenly, but the person will not. He is still moving. So according to the Newton's first law of motion, when any body is moving, it tends to be in motion. Okay, when any body is in motion, an object is in motion, it tends to be in motion. So that actually means the person is still moving. Okay, so he will fall down in the forward direction, and the bicycle will be stopped. Okay, so this is the Newton's first law of motion. Let's come to the second part. Newton's second law of motion states that the rate of change of momentum of a body is directly proportional to the applied force. And takes place in the direction in which the force acts. Okay, so the direction of the resultant will be in the direction of force, whatever, but although the Newton's second law of motion states that the rate of change of momentum of a body is directly proportional to the force. Now, what is momentum? Momentum is a quantity which actually represents the quantity of motion. Okay, if anyone is asking you how can you measure a motion? Actually, motion depends on two factors, mass and velocity. So momentum is the product of mass and velocity. Okay, this you can imagine as the quantity of motion. You can measure a motion by measuring the momentum. So P is nothing but m into V. Okay, mass into velocity. So if the mass of any object is greater, the momentum will also be more, and just similar to the velocity also. Okay, so momentum is nothing but mass into velocity. Now you can understand this law in one more way. That is, if the time of applied force is less, then the force will be higher. Okay, time is inversely proportional to the force applied on it, and that comes from the formula of derivation of force. Force is nothing but mass into acceleration. Now when you will elaborate this acceleration, it will be mass into v minus u by t. Now try to think about this force and this time. When the time of applied force is less, the force will be higher, the impact of force will be higher. Okay, or you can say this is like the rate of change of momentum, change of momentum, the time to change the momentum. If it is less, the force will be higher, the impact of force will be higher. Let us understand this situation with some example. See this. This is the first example. A fielder pulls his hand backward while catching a cricket ball coming with a great speed. Okay, so this is IPL time, and you know about everything about cricket. When any fielder is catching a ball, he pulls his hand backwards just to reduce the impact of force. Why? Because I said that when the time will be less, the force will be higher. Okay, so just you can think the opposite to this situation. When the time of rate of change of momentum is more, the impact of force will be less. Okay, so when any fielder is pulling his hand backwards, he is actually increasing the time, and by that increase of time, the force will be less. Okay, so there will not the hand of fielder will not be injured, obviously. Okay, that's why he pulls his hand backward. For athletes of long and high jump, sand bed or cushioned bed is provided at the place of landing, because when any person is doing a long jump or high jump, he may injured without a sand bed or cushion bed. He can be injured because if the surface is very flat and concrete surface is there. Suppose some athlete is jumping, doing this long jump, and the surface is like solid surface is there. So suddenly his rate of the momentum of that person, he is running from a very long distance, and the force, he has gained so much of motion. When he will jump on this surface, and if it is a solid surface, what will happen? The momentum will suddenly become zero. The time to change the momentum will be less, so the force will be higher. He may get injured, so he may face fatal injury also. So to avoid that kind of situation, we use sandbeds or cushion beds. Okay. You can understand this law by other method also. You can see this. Suppose same force is applied on two different mass object. Then the small mass object will get large acceleration. Okay, and the larger mass object will get small acceleration. Suppose you are applying the same force on just 1 kilogram stone and this car. So obviously you cannot roll the car more because the acceleration will be less. Okay, because of the mass, due to greater mass, it will gain small acceleration. That is the condition. Because the force is mass into acceleration, means the product of mass and acceleration must be constant. If the mass is high, if the mass is larger, if the mass is more, you need to apply more force to accelerate it in the same speed. Okay, that is the situation. One more way you can think of this situation, like suppose in the figure it is shown, one person is applying, an object is 400 kilogram, this is an object of 40 kilogram, he is applying same force. Suppose he is applying same force, so he can, this object, suppose this is object 1, this is object 2, if the same amount of force is applied on both the object, this smaller mass object will gain more acceleration as compared to this higher mass object. Okay, that is due to the different momentum. So momentum must be constant. Okay, so that was the second law of motion. Let us come to the third one. This is the third law of motion, Newton's third law of motion. It's very simple. It states that Newton's third law of motion states that for each and every action, there is an equal and opposite reaction. That is, action and reaction forces are equal and opposite. If you will push a wall with some force, the wall will also push you backwards with the same amount of force, okay, but in the opposite direction. Let us understand this by reading some examples. So suppose this is a recoil of gun, walking of a person. So recoil of a gun, what is recoil? When you shoot a bullet, when a bullet is fired from a gun, okay, the bullet moves forward. Okay, so this is action. So we are applying some action. So bullet, suppose the motion of bullet is the action, accelerating force of the bullet. Okay, so there is some accelerating force. Whenever there is an action, it will create equal and opposite reaction at the same time. Okay, but in the different object. So action is provided in the bullet, but the reaction will be on the gun. This gun, actually what happens when a bullet is fired from the gun, bullet moves forward and the gun face a force in the backward direction, a jerk. It feels a push or jerk in the backward direction. That is called recoil force of a gun. Okay, and those two kinds of forces are equal and opposite to each other. Okay, remember always Newton's third law of motion. It is applicable on different object. Action will be on the different object, reaction will be on the different object, but the timing will be same. Okay, as soon as there will be an action, there will be a reaction. So you remember these points. Okay, so that is called recoil of a gun, and the force of acceleration of the bullet will be equal to the force on the gun, obviously. But now you will think that the bullet moves very far, a lot of distance. It moves, up to very long distance. But the gun, actually, along with the gun, your hand is there. So it is also, opposing it, and the mass, the total mass of that gun along with the person is very high as compared to the bullet. That's why bullet moves for a very far distance. Okay. Now, let us think about this. This is we are understanding the walking of a person. Okay. The walking of a person is only possible because of the Newton's third law of motion, or you can apply analogy on that. Like, see, what happens? Foot pushes down and back. This direction is down and back. You cannot say this is down. This is down and back also. So you can divide it in two components as the blue one. Like, you see, it is, our foot applies a force in this direction. That is some amount of force in the downward, some amount of force in the backward. So it will, this is an action. So thus, action is always equal and opposite to the reaction also. So there will be a reaction. That means our body will move forward when we will push the earth surface backwards. Okay, so that is the reaction. When our foot pushes the earth also pushes us. Okay, with the same amount of force. This is called reaction. So action is always an equal and opposite to the reaction. Okay, this is what the Newton's third law says. So there is another beautiful example of boy's feet exert force on the boat. Suppose you are jumping from the boat to the bank of a river or any pond, whatever. So when you jump from the boat to the river, what will happen? You will apply a force. You will apply a force on the boat in backward direction. So as soon as you will apply a force on the backward direction, the boat will move in the backward direction and you will move in the forward direction. Then only you can jump and reach to the bank. Okay. So this is a situation where this is an action, this is a reaction. And you can think that both action and reaction are applied on the different objects. Action is in the boat, reaction is in the body of a person. Okay, this is about action and reaction. And both are the sign of or direction of action and reaction is equal. You can think of this. This is the third law of motion. So Newton has stated 3 different laws of motion. I think you have understood. Thank you very much.